Hey guys, welcome back to a new Python robotics video, and in today's video we're going to be showing you Desmos regression. So I'm going to be covering everything from graphs and tables to like forming lines. I'm going to be showing you how to do regression for simple algebra. I'm going to be showing it for percentages, how to do some tricky equations that you might not know how to do with algebra, and then also the multivariable equations with constants and things like that. Those that are super tricky, I'm going to be showing you how to breeze right through them with regression. So without further ado, let's hop right into it. All right, guys. So I have a couple questions prepared for you. So let's just get right into it. So I'm going to show you the quick demonstration of how regression works. So regression pretty much asks Desmos to guess the question, guess what a constant is for you, or not necessarily guess, but do the math for you to find out what a constant is based on the given parameters that you give it. So for example, let's say we have 4x plus 2 equals 6. Okay, now if you were to do this, you would subtract the 2 over to the 6 and divide by 4 to isolate x, and you get that x is equal to 1. Which we can also do, if we were going to do with regression, we could replace the x with a b, or any other constant, so we could do like f, d, s, a, like g, h, anything. So we'll use b for now, just to make it easy. And then replace the equal sign with a regression symbol, which is this tilde right here. And it tells you regression parameters b is equal to 1. So for this equation to be true, b would have to be equal to 1 for 4b plus 2 to be equal to 6. So the regression symbol here essentially acts like an equal sign, and it helps Desmos tell it to, hey, look, the person writing this wants you to find out what the value of this constant is. And we can use this for a bunch of different things as well. So obviously if we have like a big number like this plus like this, so like that, then Desmos will tell us, oh, this number is this for it to be a correct answer, like things like that. So that's pretty much the tactics that we're going to employ. So we'll start with question 1. If 4x minus 28 equals negative 24, what is the value of x minus 7? So one important thing to know about regression is that it doesn't work with variables. So x or y, like x and y here, it just won't work with. So that's another thing to keep in mind. So in this case, if we were to do 4x minus 28 equals negative 24, or sorry, regression symbol to negative 24, it gives us an error because x is a variable and may not be used as regression. So if you want to still use x, you can put a 1 after it, and it tells Desmos, hey, this isn't actually the variable x, it's just the number x. So in this case, it says, oh, for this to be true, x1 has to be equal to 1. So we now have to find the value of x minus 7. So if we do x1 minus 7, we know the answer is negative 6. And just like that, we've solved the first question, which is C right here. All right, question 2. The table shows 3 values of x and the corresponding values of y. If there is a linear relationship between x and y, which of the following equations represents this relationship? Now you could either look at this and figure out that the y-intercept is 18, so the b is 18, and it's a slope of negative 5, so that's d. Or, if it's a bit of a harder one, or ask you for anything other than linear, what you could do is you could type in the values into the chart here. Oh, sorry. Yeah. And pretty much tell Desmos by pressing here to add a regression, and to give you a regression for all of these. And here with the R value, it'll tell you how good of a fit is. So we know that it's a linear relationship, so we can do linear regression. But if we were going to do quadratic regression, we could also have it give us a quadratic regression, which in this case is going to be huge for it to be straight, but it'll work. Then we could have a cubic regression as well, where it looks like this, or we could do pretty much any kind of regression that we wanted to. Desmos would help us do it. And in this case, we just need linear regression, and here's our equation right here. Y equals negative 5x plus 18, which is D. So the next question. Triangle ABC is similar to triangle XYZ, where A, B, and C correspond to X, Y, and Z respectively. In triangle ABC, the length of AB is 170, and the length of BC is 850. In triangle XYZ, the length of YZ is 60, what is xy? So in this case, we're going to be setting up a proportion. So one easy way of doing proportions with regression is by doing something like this. So saying like 4 over 5 is regressed to b over 9. And it's telling us to find the value of 9 for it to match up with the 4 over 5. And in this case, it'd be 7 over 2. So that's just a quick intro into it. So we know in ABC, AB is 170 and BC is 850. And YZ is 60, so we need to find XY. So what we can do is we can do 170 over 850, which is AB over BC. And we can do the regression symbol to something over 60. So B over 60. And it'll guess us, 170. And it'll guess us that B is equal to 12 for this to be true. And the reason why I have to do it in a specific way is because AB corresponds to XY and BC corresponds to YZ. So you have to be careful to not mix those up. So since we put AB first on top and then BC underneath it, we have to put XY on top and then YZ underneath it afterwards for us to get the answer D, 12, which is the correct answer. This is just another quick practice problem if you guys want to try it out yourself, just finding the value of n. But this is also pretty intuitive. I mean, if you look at them, you know the value of n is 24 right away, so kind of just a freebie, but if you want to look into it, you can do that as well. Okay, so this is another good question. There's two ways of doing this. The first one would be with a system of equations, where you replace x and y with, a and b with x and y. So you would do like this, and then you would do so you could do this and see where the two lines intersect, and that would be your answer. Or what you can do is you can set up a system of equations, but with regression for Desmos to just tell you it. So we know that 2a plus 8b is equal to 198. So what this is saying essentially is that anything inside this box is equal to anything inside this box. So it looks just like this. So anything inside here is equal to anything inside here. So if I say that like a is equal to 2, it tells me, hey, a is equal to 2. So in this case, we're telling it, hey, 2a plus 8b is equal to 198. And it's telling us here that with the parameters, a is 99 and b is 0. But that's not exactly true. So we need to give it the second equation, which we can separate with a comma by telling, and this essentially tells Desmos, hey, we're giving you a new equation to factor in as well. So 2a plus 4b also equals 98. And it tells us what is the value of b. So it tells us right here, a is -1 and b is 25. So our answer is 25. Next question. You guys can try this by yourself first if you want. It'll be the exact same way that we just solved it. So if you want to pause here and try it yourself, you can. Okay, so the solution is we're going to set up another box, pretty much, 2 boxes. And we're going to say a wire with a length of 106 inches is cut into 2 parts. If one part is x and another part is y, the value of x is also 6 more than 4 times the value of y. What is the value of x? So we're going to say that x plus y, but remember, we can't use variables. So we can use just the number x and y, x1 and y1, and set that equal to 106. But we also know the value of x, so we can write x1 here, is also equal to 6 more than 4 times the value of y. So 6 plus 4, y1. And that tells us that, hey, or it asks us, what is the value of x? So in this case, the value of x is 86. And that's our answer, which is D. So this is another tricky percent problem, but can be solved really easily with Desmos, so you don't even have to know percents at all. It says the positive number a is 230% of the number b, and a is 60% of the number c. If c is p% of b, which of the following is closest to the value of p? So we'll set up two regression boxes, and we'll say that a is equal to 230% of b, and a is also 60% of c. So 60% of c. If c is p% of b, what is the value of p? So we can say here that c is p% of b. And in this case, Desmos says, oh, the value of p is 383, which is D, which is the correct answer. Okay, so this is just another really simple problem. You could just guess and check here. Or you could do percents the proper way, however you want to do it, or you could just use regression. So we'll set up our two boxes. 13 is p% of 25, and it says that the value of p is 52. So 52% of 25 is 13, which is correct, and we can check it right here. 25 is 13, which is the correct answer. Okay, so this is another regression question, but this one essentially uses numbers instead of actual constants, like this question here, but it's but with numbers instead. So we have the regular price of a shirt is $11.70. So the regular price at a store is $11.70. So we'll set up our two boxes. 1.7. So the sale price of the shirt is 80% less than the regular price, and the sale price is 30% greater than the store's cost for the shirt. What is the store's cost in dollars for the shirt? So let's call the regular price R, and we'll say that that is equal to $11.70. The sale price is 80% less than the regular price, so we'll call sale price S. So sale is equal to the regular price minus 80% of the regular price, which is just is 80% less than the regular price, which is essentially the same way of saying 20%. And the sale price is 30% greater than the store's cost. So the sale price is also the store's cost plus 30% of the cost. And what is the store's cost in dollars for the shirt? And it tells you right here that C is equal to 1.8. So the store's original cost is $1.80. Next question. So this is ratios, essentially the same question that we just tried, or that we did earlier at the start of the video. So the ratio x to y is equivalent to 9/5. If the value of x is 162, what is the value of y? So if we know that x over y is 9/5, we can then do regression, and we know the value of x is 162 over b. And in this case, the value of y here, or we can do y1 to make it simple, the value of y is 90 right here. So this was essentially the question that we did like up here, just in a different style. Just asking you, just instead of actually telling you how many you originally have, it says how many faulty items are in the sample. So 80% of them are faulty, and 80%, and there are 88 faulty items. So in this case, we can set up our two boxes, and we can do 80% of B is equal to 88. And in this case, 80% of B, in this case 110, is equal to 88. So Desmos is saying that the original number here is 110. So how many total items are in the sample? 110. And simple as that. So, two customers purchased the same kind of bread and eggs at a store. The first customer paid $12.45 for one loaf of bread and 2 dozen eggs. The second customer paid $19.42 for 4 loaves of bread and 1 dozen eggs. What is the cost in dollars of 1 dozen eggs? So this is pretty much the percent problem, or the store's cost for the shirt all over again. So we will say bread is B and eggs are E, just to make it easy. So we know that 1 loaf of bread and 2 dozen eggs, so we'll call 2 as G, because we can't actually use E because it'll think that it's a number E, like 2.7. So we have to use G instead, or well, any other number or letter. Sorry. So 2 dozen eggs is equal to $12.45. The second customer paid $19.42 for 4 loaves of bread and 1 dozen eggs. So 4 breads and 1 egg is equal to $19.42. And it asks us, what is the store's cost in dollars of 1 dozen egg? So the eggs right here are $4.34, which is answer choice D, right here. This is a longer style question. This one uses proportions, and then just defined it, and then uses Pythagorean theorem to then find what the area is. I'll go over this one. If you guys want to try it first, you can. This one's definitely slightly longer, but much easier to use with Desmos and regression. So if we know that AB right here is the square root of 34 units, and AC is 3, and we know that CE is 21, we have to find what is the area of A, D, and E. So we're first going to use regression to find, instead of a proportion, to find BD. BD. So if we know that AB is the square root of 34 and AC is 3, we can then do the regression symbol, and we need to find BD. So we don't know what that is, so we'll say that's B, over CE, which is 21 units, right here. So we know now that B is this number right here, which I think is the square root of 1,666. Yeah, it is. Perfect. So we then know that AED is AB plus BD, which is the square root of 34 plus the square root of 1,666. And now we need to find DE, because remember the formula is 1/2 base times height. So we can use Pythagorean theorem. So A squared plus B squared equals C squared. And we can say, okay, so we know our C squared is this number right here. So we can put that in. And we can use a regression symbol. And then we also know that AC plus CE is the base. So AE is 21 plus 3, which is 24. So we can write A as 24. There we go. And in this case, we only have one constant. So Desmos is going to guess what our constant is. So it's going to say, oh, for this to be true, B has to be 40. So if we go back to our formula, base times height, we know that it's 1/2 times 40 times 24. And our answer is 480, which is right here. And here's the last question, or sorry, the second to last question that we have. This one's a little bit trickier, but also pretty easy. And this, we use some more parameters to actually solve this question. So we have that the cube root of p squared is equal to t to the 9 over 7. In the given equation, p is greater than 1 and t is greater than 1. If t is equal to the p to the 3n minus 1, where n is a constant, what is the value of n? So we're going to set up our regression boxes. And we're going to say that the cube root here is p squared is equal to t to the 9 over 7. And we're also going to say that t, right here, t is equal to p to the 3n minus 1, right here. And it's asking us to solve for the value of n. But in this case, we also know that p is greater than 1 and t is greater than 1, not equal to. So we can tell Desmos, using these curly brackets, that p has to be greater than 1, and t also has to be greater than 1 for this to work. And in this case, once we actually put in these extra 2 parameters, it tells us that the value of n is 0.506, which is the correct answer. And if we were to change these numbers, pretty much we force Desmos to solve it in a different way, to solve it with these new values. So whatever you put in with these parameters here, also changes a little bit of what the answer will be. And here's the last question. This was the same question that we did earlier, but just another practice one. So the weight of sample A is 468% the weight of sample B, and the weight of sample A is 0.78% the weight of sample C. If the weight of sample C is p% the weight of sample B, what is the value of p? So let's set up our regression boxes. And we know that A is 468% of B. And A is also 0.78% of C. And then we need to find, and if the weight of sample C is p% the weight of sample B, so C is p% of B, what is the value of P? So right here, P is 60,000, right here. And that's everything I have for you today. So thank you guys so much for watching. I really hope you enjoyed and you learned something new. If you did, don't forget to hit that like button and subscribe down below. And I'll see you in the next one. Peace.